Hey guys, welcome back to the CISSP objective number 4.1.12, and in this we are going to explore some concept related to edge networks. When we say edge networks, this is nothing but the edge which is nearest to you. That means a parameter. When you are touching your enterprise network, what happens on the parameter? That is number one. If you are also connecting from home, there is something like a parameter which is defined on your particular system as well. That is the reason why earlier the same topic we used to call it as parameter defense, but now we started calling it as edge network, because the edge has moved. It is just not confined to your company network itself. Now it has gone beyond that. So with that said, I think let's take it and try to churn up some kind of concept questions here, and accordingly we will try to discuss some more concept during this journey, right? So let's go ahead and go to the question number 1. Okay guys, let's go through this question, right? Hey guys, let's see this question, and it says the placement of routers, firewall and IDS, IPS devices in a network parameter security architecture is primarily aimed at protecting internal network resources from external threats. Is it okay? Router, firewall, IDS, IPS, all protecting you from the external threats? I think very much true statement, right? Whenever we place router, firewall, IDS, IPS in the network parameter, we are trying to enhance the security at the parameter level, right? So that whenever there is a threat coming from the external side, we are able to filter that out. So I think very much there is no harm to say that this particular concept is a true statement, right? With that said, let's see. So let's see this particular question. Hey guys, interesting question here. It says in a defense in depth strategy. So what is a defense in depth strategy? Where we implement multiple layer of defense, right? That is what. And it says IDS, IPS devices are typically deployed at the outermost layer of the network parameter. So one way we are saying defense in depth. Another we are saying it is just restricted to the parameter defense. I don't think that's the right statement to say. In a defense in depth strategy, we place IDS, IPS in multiple points or multiple layers within the network architecture, which may also contain the network parameter, internal network segment, or any critical infrastructure segment. That is where we are going to place IDS, IPS. I am not saying each and every segment you place one IDS, IPS. It should be always based on the kind of data which is being handled by that particular segment. So based on that, you are going to put your IDS, IPS. So very much this particular statement based on that can be tagged as false. I hope this concept helps understanding the defense in depth strategy, right? So defense in depth means having multiple layers of the controls. That means you are trying to check if only at parameter level is sufficient or not. With that said, let's go and try out this particular question. Hey guys, very easy question, simple question. It is asking you routers are primarily responsible for inspecting and filtering network traffic based on predefined rules. Let's critically examine this. So routers are basically for routing, isn't it? That is their basic functionality. Are they good for inspecting? They are good for inspecting the packet headers. Router does not go on the content level, right? It doesn't go to the payload level. And if you need to go to the payload level to do the inspection, when we say inspection means it is more about the content inspection. I don't think router has that capability. So this goes down. On the other side, filtering. Does router does filtering? No, it is just routing, and if a particular packet is not intended for that particular network, it will not entertain and only authorize only that intended packet is allowed to come inside your network. So even filtering is also not the capability of the router. Filtering is the capability of the firewall. So none of the functionality is matching here, right? And because of that, this particular question can safely be tagged as false. I hope very simple question and it make complete sense to you. With that said, let's try to see the next question. Hey guys, lucky day, I have another easy question on your screen and it says a firewall and an intrusion prevention system serves the same purpose. Is it the same? Not at all, man. These are completely different devices. A firewall is basically for filtering and a intrusion prevention system is for inspection and response of a particular packet or a particular kind of data which is coming inside your organization. So can they be used interchangeably? Are they same? Not at all, and that is why this particular question is completely a false statement. Easy picking for everyone. So with that said, let's go to the next question. Hey guys, let's see this question, right? Very much a comparison between firewall and IDS IPS, right? It says a firewall is primarily concerned with inspecting the content of the network packets to detect and prevent malicious activities. Is this particular statement true? Not at all. The firewall is not going to inspect, do the content level this thing to see if there is a malicious code. Yes, if a particular firewall is a very specialist firewall, let's say it is a web application firewall, then it can definitely go on the content level, and it is the specialist firewall for identifying any kind of protocol which are related to the application layer. So this is a very smart firewall. But here we are talking about generic firewall and it says detecting and preventing malicious activities. I don't think that is the role of the firewall. Firewall is basically to inspect the particular packet and make a decision. As the rule matches, it will either allow or it will deny or it will forward the particular packet. That is the role of the firewall. While let's see, okay, so until this we are no to say this as a good concept. The other thing says, while an IPS focuses on controlling access to network resources based on predefined security policies, I think it has flipped. This is the role of firewall and this is the role of IPS, IDS IPS, very much. So it is a flip between the roles of the two devices, and that is the reason why I can safely tag this particular question as a false one. I hope this is clear to you, and let's go to the next concept. Good guys, another question here, and it says, unlike a firewall, an intrusion prevention system operates primarily at the application layer of the OSI model to inspect network packets and detect potential security threats. So it says unlike a firewall, right? Unlike a firewall. So at what level normally firewalls operate? Most of them are level 3, level 4. OSI layer 3, layer 4, that is what most of the firewall operates. Yes, some of them are there, for example application layer for firewall, anything related to proxy, yes, that goes to the application layer, but most of them come under level 3, level 4, right? So that is very much right. It says intrusion prevention system operates primarily at the application layer. Yes, very much true. If you need to do content level inspection, you have to go to the upper layer of the OSI, and that is where this particular statement makes sense, right? Because the IDS IPS now has capabilities to go and do the content level inspection by using the subordinate certificate. It can even decrypt those particular packets and go inside this and see what is there, and based on that match it with certain rules and flag it as a deviation just in case it is there. So very much a true statement. I don't find anything wrong in this particular statement. So very well you can take it as a concept. With that said, let's go to the next level. Hey guys, another easy picking, and this talks about the positioning of the firewall or the IDS IPS. So the question says a firewall is considered as a first line of defense in network security, and a intrusion detection system is often deployed as a secondary layer of protection to complement the firewall capability. I think very much right, because if you see a typical network architecture from a perimeter security perspective, what happens is first comes your edge router, and edge router may not have security capabilities most of the time. It is more of a IT device which do the routing and let the concerned packet come inside. Then the first security device we are going to place, it might be a firewall, and after a firewall we then implement the IDS or IPS. We put the IP, if this is the case of a IDS, we are going to place it in the parallel mode. We also call it as shunting mode, okay, because IDS is a detective device. It is just operating in a passive mode, and if let's say IDS is down, then it will be a hindrance, right? It will become a bottleneck. So we always try to put IDS in the parallel mode, right? That means in the shunting mode. Whereas if this is IPS, you don't have this particular option. You have to place your IPS in line with the network traffic for sure. And yeah, that was another concept which I wanted to explain you, but very much you can see it is the first line of defense and it becomes the second line of defense. So I don't find, or I will not hesitate to call this particular option as a true statement, and you can take it as a concept going further. With that said, let's go and see the next parameter. Hey guys, again a cracker for you, right? An easy option for you. The question says an intrusion prevention system is a passive security control. Not at all. So IDS is what you can call it as a passive control or a detective control, but IPS is very much a preventive control, or you can also say it has the response capabilities as well. So it's a reactive control as well at the same time. So the question is, an intrusion detection system is a passive security control that only detects and alerts on security incident, which is completely a wrong statement, and that is why this particular question turns out to be a false one. With that said, let's head on to the next concept. Hey guys, very simple question. It says a key difference between IDS and IPS is that IDS operates in a passive mode while IPS operates in an active mode. I think very much true. We have already discussed this particular concept. IDS is a passive device, IPS is an active device because it is able to take certain action in the real time as well. So very much it's a true statement without a doubt. And with that said, let's go to the next one. Hey guys, this is an interesting question and it says NAT and PAT. So first try to understand what is NAT and PAT, right? NAT stands for Network Address Translation. Network Address Translation. Now this is a particular protocol which can help and save a lot of money for the company. Let's say many people want to access internet in a particular company. We cannot give each and every guy, and we cannot purchase each and a public IP for each and every guy. That will be a lot of costing, right? To reduce that costing, to lower that particular costing, we can definitely use NAT, in which what will happen is, let's say this is your organization, there are a lot of employees inside this, we have implemented NAT here, and we have only configured, let's say, 1 or 2 public IPs here. So many people can connect to this NAT, and what this NAT device will do, it will change the header. It will change the header for your private IP, put a public header on top of it, get the things done from the public IP, maybe a Google or whatever site you are accessing, and give the data back to them. So this way it just not only prevents you from the costing part, you don't have to use multiple public IPs at the same time. It can also increase your security as well, because anybody who is sitting outside will not have any visibility about your internal network structure or architecture, right? That is a great plus. Now only one limitation in case of NAT, because what if, because we are, let's say we are using only one IP and there are multiple people accessing at the same time. Even though this can be managed, but if at the same point of time everybody accessing the same thing, this can lead to a little bit of congestion, right? It can lead to a little bit of delay. That's not good, right? That is a concept where we brought in PAT. PAT means port address translation, and we all know there are 65,536 port, too much. Out of that, even if we are using a portion of this, we can address a lot of connections at the same time. Let them come concurrently. There is no problem in that, right? So I think I would say PAT is the advanced version of NAT, number one. Second thing, we are able to save more money by using PAT, again another important thing. And please understand, the mapping between NAT and PAT, right, in both of them can be static mapping as well and dynamic mapping as well. In static mapping, you define if the request comes from this particular IP, take this IP through this, or take this IP to this particular IP. We can do that static mapping or routing. On the other side, dynamic routing means any particular port available or any particular public IP available that can be used at the same time. So that's the basic difference between static NAT and you can say dynamic NAT. I think I have spoken a lot. It's time for us to talk about the question. It says NAT and PAT are essentially the same. Actually, they are not essentially the same, but question is also telling you the other part of the statement, which says with the primary difference between that NAT maps multiple private IP addresses. Is that true? That NAT maps multiple private IP addresses to a single IP address. I think it makes sense, right? Multiple private IP to a single public IP. That means this is single public IP, these are multiple internal users, right? Makes sense to me. While PAT maps a single public IP address to multiple private IP addresses. I think this is also true. So it is just that they have tweaked the particular sentence here, but end of the day they are saying the same concept, isn't it? I think the way it has been put, the major difference they have not brought up here, even though this looks like to a true statement for me completely as of now, but let me also highlight the major difference. The major difference is in NAT we do not use a port. We don't let it go through a particular port, like the choice of ports is not there. There might be a default one single port, that is where everything happens. That can be restrictive at times, right? So in NAT, by using the IP address plus port, the particular connection makes a socket. It makes a socket and then the communication happens. In NAT, normally not port, only IP happens, right? In case of PAT, that is where we use NAT and the port as well. That can be also called as a socket, right? And that is done. I think you understood the basic difference between NAT and PAT. And based on that, I can tag this particular question as true. And let's go to the next question. Hey guys, very simple question now, because we have already discussed this. PAT is more suitable than NAT for environment where large number of internal hosts need to access the internet using a limited number of public IP addresses. I think that is very much the advantage of PAT over NAT. So this particular statement, I would like to tag it as true, and with that we will move on to the next question. Hey guys, let's discuss this. The question says PAT introduces additional complexity and overhead compared to the NAT, making it less suitable for a small scale network with a limited number of internal hosts. I think very much true, because obviously in case of PAT we are using more ports. Obviously there will be more complexity, right, when compared to the NAT. So this particular question is very much a true statement, right? It is very much a true statement. With that said, we'll go to the next question. Amazing guys, very simple question, very easy food for us. It says next generation firewall are primarily focused on filtering traffic based on IP address and port number. I think that's the role of a layer 3 firewall. layer 3 firewall, and that layer 3 firewall can also be called as a packet filtering firewall, isn't it? That cannot be a next generation firewall, because a next generation firewall just don't have the filtering capabilities, and that too I think this will work on upper layers as well. It will also have IDS capabilities, antivirus capabilities, DLP capabilities, authentication capabilities, and so more. So I think based on that, this particular statement stands nowhere, and this particular question is a false question. With that said, let's go to the next part. Amazing guys, amazing question again. It says circuit level firewall operates at the application layer of the OSI model. Is it true? I don't agree with that, right? Circuit level firewall makes a circuit, and where is the circuit is made? That is on your layer 5, that is on the session layer, right? That is where the circuit is created, right? So circuit level firewall operate at the application layer of the OSI layer. I do not agree with that particular statement, so I will mark it as false. And let's see the next statement. And inspect incoming packets to determine whether they meet specific criteria. So for doing the content filtering in a much better way, you need at least to be on layer 7. And when it comes to circuit level, it operates on the session layer. And when we say session layer, it can normally be only monitoring the connections, right? Monitoring the connections. And when we say monitoring the connections and the session, that means mostly web based sessions, right? And that is where the circuit proxy normally is either a like it normally tracks a TCP connections, right? Or TLS and TCP. Based on that particular connection, it can operate. So I think very much a simple thing to find out from this particular option, and I can safely tag it as a false statement. With that said, let's go and check the next statement. Okay guys, let's talk about this question, right? And very good question. This question says stateful inspection firewall maintain information about the state of active connections, allowing them to make filtering decisions based on the context of each packet. And that's absolutely right. That is how your stateful firewall actually works. It actually maintains a table. When a particular connection comes in, let's say there is a particular protocol request has come in, and as per expected, there is a particular sequence of packet which has to go as per this particular protocol. So what it will do, it will maintain a record of when this particular connection came in, which particular protocol sequence of packet came in, and the next time if there is any deviation in the packet from any of the side, if there is an anomaly detected there, that will definitely be caught and the decision will be taken. So that is how your stateful firewall actually works. Very much important, especially on cloud kind of thing. Very important control.